Hi, and welcome back. So in the past video, we were taking this function. We had f of x is equal to 8, or is equal to e raised to the 8x times the square root of 7x plus 12, all of that divided by x minus 6 raised to the ninth power. And we were trying to just take the derivative of that expression, and we were doing that by using logarithmic differentiation. And we did a bunch of this in the last video, and we got down to this point. One thing I should say before I go too much farther is I misspoke in the last video, and I said that we had gotten this pretty much down to the final form, and this we've done a good bit of it, but this is not the final form that the answer should be in, because remember, what are we trying to find? We're trying to find f prime of x, right? We are trying to explicitly define f prime of x just in terms of x. So I misspoke in the last video where I said that we were, or I might have mentioned, the way I phrased it, it might have sounded like we were done. And I want to make it very clear that the point we are at right now, we're almost done, but we are not 100% done. So now I'm actually just going to go ahead and get us 100% done. So now what I'm going to do is all we have to do, and there's really just one more step. We can kind of clean up this expression a little bit in here, right? But really there's just one more step to completely clean this up. Because we just have to define this explicitly. We have to define this explicitly we have to define f prime of x explicitly in terms of x. So what do we have to do? All we have to do is we just have to multiply by our function. We just have to multiply by f of x. And we already know what f of x is, right? f of x is right here. F of x is equal to all of this stuff. All this stuff that we started with. So now all we have to do, and I'm just going to write this, well, there. That'll be good enough. Hopefully I'll move this around and keep figuring out keep looking back to see what f of x was. But for right now, all you have to see is that we are going to multiply. We're going to take all that we had. So all of this expression we've got, and I'll keep this in. Oh, didn't mean to do that. So we've got all of this expression, this 8, plus, and let's actually simplify this a little bit. We've got 7, and we can multiply this 2 into our denominator, right? So we have 7 divided by 14x, so divided by 14x, and plus, what's 2 times 12? That's 24, right? So 7 divided by 14x plus 24. And then we can also write this 9 as our new numerator, right? Because 9 times 1 is just 1. So minus 9 divided by x minus 6. And then all we're going to do is we're just going to multiply this times the original function, times our f of x. And so what is our f of x? Well, it's just might have to keep switching back and forth here, but this is our f of x. It's right here. So we have our f of x explicitly defined in terms of x. So I'm actually just going to scroll up, and I can still see that even though you might not be able to see all of it. So, but hopefully you've written it down maybe, but and you can also kind of see it right here. But anyway, I'm going to erase this f of x, and so now I'm just going to write f of x as it was explicitly defined. So we are going to multiply all of this times e to the 8x times the square root of 7x plus 12, and then all of that divided by x minus 6 raised to the ninth power. And now we have gotten this into the form where this, choose a good color, this is our final answer. We are completely done. Unless there is some really painfully obvious simplification that you can do when you finish a logarithmic differentiation problem, don't even try to simplify. Normally these questions aren't meant to figure out just how much of a rock star you are at simplifying these really long algebraic expressions with all these fractions and everything. So most of the time, unless your test might say simplify, the derivative and simplify the derivative of f of x, unless you see something like that on a test, which you most likely won't see, but unless you see something like that, this form is absolutely fine. You don't need to worry about simplifying this expression. I know this looks really big and pretty mean and nasty fraction and expression, but this is perfectly acceptable way to write the answer. So anyway, I think that's it for this video. Keep watching, and I'll just keep on doing more of these review problems. Thanks for watching, and I'll see you soon.